So, energy and simple harmonic motion. Okay, so we know, what do we know about energy so far?
That it's conserved.
So we know that work right now is the sum of the kinetic energy
I'm just gonna go through my mind now.
and potential energy of a system.
Yeah.
But
Yeah.
there's also another thing called elastic energy. And this is what we're going to talk about today. This is in relation to springs.
Okay.
Okay, so there's actually another part of this that we won't get to in this class, but the entire formula is more than just when we have m1 v1 v squared, like this whole thing.
Yeah.
It's more than just the 4 terms total. It's really 8.
Oh, awesome.
Okay, so
Can't wait till this test.
let's talk about elastic energy, or the work done by an elastic system. So what would be an elastic system? Elastic system is something that stretches. So that's why we are applying that to springs.
So it's
Not that, Carter. Okay, so the work done,
So,
I'm sorry, I don't pick up
the
quickly.
work done by an elastic system
No.
This sweater shrinks and longs. They're like more comfortable walking.
looks like this. So your elastic energy then is the term 1/2 k x final squared, or 1/2 k x initial squared.
so they equal each other.
If work is 0.
Yeah.
Okay, so k is the spring constant, remember?
Mhm.
What is x?
The distance, or like the length that the spring can go to.
Yep, we're gonna call that displacement. And of the spring. Okay, so hopefully when we are defining our frame of reference to start our problem, hopefully one of these two can be 0. So like the unstrained spring length, because then one of the now 6 terms of our energy formula will then be 0.
Yeah.
Okay, so let me show you what that all looks like. So kinetic energy, potential energy, elastic energy,
Oh my goodness.
Is this it for today?
actually it kind of is.
Yeah, see, look at that. We can get through it pretty quickly.
Yeah, I know.
Except I've got freaking play practice today, so I can't do my homework, which is very annoying.
Okay, so I want to see if I can. There, that's more better.
I was just hungry to walk that way.
All right, so let's do an example of this work.
I could really go for a cookie right now.
I have one, and they're not very good. They're
No, I don't want big cookies. I feel like they're too much.
Let's
Thanks,
do number
Nina.
32 on your
I don't
homework.
mean it that way.
Or I mean in your book. All right, so grab your book, guys.
Restrict myself like that.
Yeah, it's tough. I
Carter, your book.
my book.
Your book, page 305.
I don't mean like the big cookies too much as in like too many calories. I mean it's too much as in like it's so like gooey.
Yeah, it is too much. I ate it all right before. I was so hungry. I didn't eat hardly anything yesterday, and my stomach felt weird. So I was like, I'm gonna mow down on this big cookie, and I ate the whole thing. Usually I don't eat it like all during 10-minute break, and I ate it all, and I feel absolutely like dog shit.
Yeah. I just feel like
Ellie Jacobin shit her pants.
what?
She would never eat them.
Ew.
Like actually, she would have to like go to the bathroom and like
Oh.
Hershey squirt them out.
Ew! Stop! That's awful.
I got that one from Lennon.
That's crazy.
All right, 32.
That is actually crazy. Hershey's
That's
squirt.
pretty good today.
What?
Yeah, and I thought what Drew was saying was like so stupid. I was just like,
Yeah,
shut
I was
up.
like,
Like,
why was
I was
he-
like, that's what make rap, like that's what makes rap music rap music. Like, he's getting all technical. It's like, shut the fuck up.
All right, number 32.
The rifle fires. Who is it? Jared Ertman?
Okay. 2.10 times 10 to the minus 2 kilograms.
Miss Bishop, when you're done, I have to ask you something.
Okay.
Say it,
Oh.
just say it.
Did you hear about Megan Urban?
I did.
Bro, that bitch
Oh.
hit the car
Twice, and then drove away.
Wait, what? Twice?
So she's like this
What a dumb
horrible.
blonde.
Okay, hold on.
Come
I
on,
actually
she's
hold on,
gone.
Carter. I saw
She's
it.
Gollum.
Hold up.
She's what?
Gollum.
What does that mean?
Like that Gollum,
Gollum
like
from
no
the Lord
hair.
of the Rings.
Look up a picture of Gollum.
I'm gonna do it.
Wait. Show her.
Thank God.
Okay, but no, explain to me how the accident took place.
Okay,
So
I
let's
don't
use
know. So
let's use a
okay,
couple of
okay, I
calculators
saw
here.
it. I saw
Here,
it.
come in,
I
do
witnessed it.
Okay, this is Libby's. This is Megan's, right?
Okay,
She's pulling out. Hits it like that, right? She obviously saw it because she looked, came back in, looked at it, saw that it came off, and then went like that again and drove off.
And broke like the bumper.
What an idiot!
And then she drove away.
Yeah.
Did you see the text that she sent to Lou
Yeah,
last
Libby
night?
showed me this morning.
Wait, she sent a text?
Yeah.
What'd you say?
She was like, I'm sorry I'm not telling you this in person, but I didn't realize that. I knew I hate your car, but I didn't realize that it was like damaged.
Like, there's
or whatever.
no
She's like,
way.
I received
So-
the
so
obviously
even-
tell.
okay, if she didn't know it was that bad, but that means she just was trying to get away with it.
Yeah.
And
Yes.
that's that she
Yes,
was
and
caught.
run off without it being seen. Yep.
That is crazy. That is actually insane.
Like, imagine if no one was out there, Libby, like, we literally wouldn't have known who hit her car.
Well,
no,
there's
everyone knew-
cameras,
everyone knew her
right?
car. Everyone knew her car.
Oh, really?
Yeah,
Yeah,
I-
ever since she started coming back to school, she took my parking spot.
Mhm. And also
She was so pissed off.
people also saw how bad we were making fun. I said in the morning, I said, dude, when she backs up, she's gonna hit her car because it was
Really?
so bad.
Really?
You
like predicted the future.
Okay, but it was such a bad.
And Dr. Swaggle's bus got hit the night before.
Yeah, I
That's
heard about
crazy.
that too.
Oh my god. His freaking bus? Yeah.
That's
All right,
that's
so
just-
here we go.
Okay.
The mass of the bullet.
I could have given him a ride.
X is
Right.
the stretching of the spring.
Oh!
You have to determine if these are final and or initial.
Okay.
Gotta keep the
Okay,
Well,
Carter.
mass is obviously constant.
Bro, we're like naked today.
What?
Ah!
Did you say?
This sweater shrunk in the wash.
Okay, guys. Shh.
Sorry. We'll get this done.
Wait, hold on. Where'd you get the 6 point something?
Pellet rest and I compress.
From the problem.
Spring has a negative
stupid?
mass and is compressed by.
It doesn't say that in the problem though.
Okay.
Am I dumb?
Did I read a different problem? The pellet rises to a maximum of 6.10 meters.
Oh.
Okay, so then-
I think I might be blind.
So then is the X, wouldn't the X be negative? Because it's compressed.
Okay, so maybe we want to draw a picture of this.
Yeah.
So we got spring is compressed. Because the spring length is that. Compressed it's that. We got a little bullet here.
How are you drawing this? Just like a circle and then.
The bullet.
But it goes straight up.
You're right. You're right. Now let's pretend that forward is up. And it goes 6.1 meters. It's compressed from an unstrained.
So it's compressed from unstrained. So that means that it's like in,
9.10.
and this is your X distance.
Yeah.
Oh, okay.
Negative 4. Would the X distance still be the other area? Like,
Oh yeah, you're right. My
it'd
bad.
it'd be the amounts changed. Like that, yeah.
Thank you.
And then the bullet takes up that compressed space. And then it's fired from there. And it goes 6.1 meters.
But it goes up, doesn't it?
Yeah, so we're just imagine that it
Yeah.
goes.
We'll just like turn it. Yeah.
Okay, so then we have
I can do
to.
that.
Height is
So-
obviously final.
Yeah.
Gravity is constant, mass is constant.
And then X.
The final is gonna be 0 because it's max height.
Oh, that's not super helpful.
But X is
Because we're trying to find.
initial right now, right? Right now X is initial, and then after, then X will be final.
Well, we have, okay, so we have X, H, G. We have it all. You can put it all in. You know, oh, we don't have initial velocity.
We can find it.
Do we need it?
Okay,
Because the initial velocity should be,
V final would be 0.
V final is 0.
But the initial would not be 0 because that's the moment it's released. So it's height
I'm
initial
running out of
0.
space.
I said that velocity initial was 0.
How?
I don't know.
Well, did you?
Well, if it's not shot, isn't it 0?
Yeah, but did you have? Okay, well then V final isn't 0 then.
I did have V final with 0.
You had both at 0.
Mm-hmm.
Because it ends up on the ground.
Okay, that seems odd, but I mean it works out in my favor.
You said that seems odd.
Odd, indeed. Okay, so I did say that this was 0, and this was 0.
And
What
then
else is
height
0?
initial.
MGH.
Yeah.
Okay, that's 0. Anything else is 0?
Shouldn't the spring constant final be 0 because it's out of the spring?
This one is 0, yes.
Okay.
Okay, so then
Be right.
that's 4 of the 6 that are gone.
Awesome.
So it's just 2 mgh final divided by x initial squared.
Where'd you get the 2 from?
1/2. So
Oh, got it. Okay, I'm sorry. You're
equals,
already ahead of me.
It's okay. Equals. Let's do it. The fraction here 2.1.
So here it doesn't really matter, Carter, that your x should be a negative number, but it doesn't matter because you're going to square x anyway.
8. And height final is 6.1. Then x squared x is 9.1. E negative 2. 27.59.
What?
Did I do it wrong?
I got 303. Did you square x squared?
No, I did not. No, I did not.
That'll make it a lot
X
bigger
is
of number.
squared?
Yep.
You know, how
Oh,
do I edit?
yeah.
How do I edit?
Just go.
Go
back to
do
the
second answer, second, and then enter,
Yeah.
and then you should be able to go back. Like just use your arrows.
Wait, why don't we just?
No,
we
I
don't
just,
have X, so why would?
mine's not.
You do
Wait,
have
we do
X.
have X.
I'm not doing it.
What am I doing?
Okay.
Yeah.
Maybe I forgot.
Well, this is an older one. It's not.
I
Maybe
know.
a nice new fancy one. I can put it all back in if I need to.
Here it is. If you just keep doing second, so like here we got answer, or there's that. You can just keep going back and getting all the different things, or shoot, why is it? Why does it cycle through all these things?
I don't know. I'll just put them back in.
No, it's ready,
Oh,
it's
you got
ready.
it in there.
I got it now.
Squared. 3.195.
That's what I got. Okay. Let us look at number 33 now, because that'll be a good thing for you to know how to do when it
What's the
gets
spring
to
constant unit again?
newtons per meter.
Gotcha. Another example?
33.
Easy enough.
All right. A 1.00 times 10 to the negative 2 kilogram. I almost said kilometer.
I'm so.
Block is resting on a horizontal frictionless surface, praise God, and is attached to a horizontal spring whose spring constant is 124 newtons per meter.
Show parallel.
The block is shoved parallel to the spring axis and is given an initial speed of 8 meters per second, while the spring is initially unstrained. What is the amplitude of the resulting simple harmonic motion?
Oh, isn't that like the angle we defined?
No. There should be a formula for you to find amplitude. But what I want to do is show you a picture.
I feel like we've done that. Wasn't it P for us before though?
No, maybe not.
Was it A?
It's capital A.
What was I thinking?
Oh, yeah, I remember amplitude. We learned this.
You do?
Well, we learned it like days ago. Like,
which was like 2 weeks ago.
yeah.
Okay, so let's talk about what's happening at each of these parts of the wave.
I don't think I have a note.
All right, so
It's like strained and unstrained.
at this point right here,
Stretched out.
your velocity is 0.
But the spring is all
And so-
raised up. Same with that one.
And so, and just as it is here. But your acceleration is at its maximum. Because remember what acceleration means. It's your change in speed. So you're at 0 here and you're going to increase your speed. That will only be, like, that's where your acceleration will, that change in speed will be the highest. At the point in the middle then, this is where your velocity is the highest. But acceleration is 0.
Oh, okay.
Because acceleration means change in speed. And if your if your speed is not changing at that point, you have no acceleration. Okay, so if we know that we're trying to find amplitude, which is at this point right here, it means that we're at A max and velocity equals 0.
Yeah.
So looking on our formula sheet, what's a formula that we could use to help us with this?
My guess is gonna be
This is one
some
of our.
pretty bunny over there.
Look, Carter, is this cute?
Oh.
Oh.
Would it be one of our
That's
original
pretty funny. That's pretty good. That's pretty good.
problems?
No, there's probably a Vmax formula someplace.
Oh, yeah. So
Oh my
Vmax equals A amplitude times W,
Ms. Bishop,
which is
are you doing Vmax? Yep, that's what I was thinking.
yeah.
Okay.
Which is
So-
the velocity.
So.
Wait,
What
is W?
what we don't know what angular velocity is, but we know a formula for it.
That is
Boy.
2 pi divided by.
But we don't have a t in our data table, and so I'm using this one because I've got m and k.
Yeah, I just read out the first one.
Oh, that's okay. That's okay. So now I'm going to put this in for omega in my Vmax equation. Maybe I should have solved for a first.
Well, K. Well, I can tell you that which is
But now really a equals Vmax divided by the square root of k divided by m.
okay.
Okay, so I do need to know that.
K is.
Okay.
Okay, so now using my data table and what I know,
Oh,
I'm starving. I'm so used to this class being the third.
I know it's terrible.
I mean, at least we have first
Okay,
lunch.
don't look at some
I hate first lunch. So it's so
I hate first lunch
It's
too.
so short.
Paste. Let's see. Okay, yes.
Ooh.
No.
I like both of them. I think both.
Okay, so now using our data table, what can we do with this? Where can we put some zeros?
There's no height, right?
Right? Yep.
So we get both of those. Our final velocity
Is
0.
okay.
And if we have a spring, don't we both have both x?
X's.
No.
One of them might be 0.
Are you out? Is it
What size do you have?
not you throwing it away?
But it still has an eraser. Oh, if the eraser is gone, then it doesn't pay. You need a pencil, Carter?
Keep the lead.
There's no lead in it. It was
Oh
dead.
my gosh.
I'm sorry, I get very upset when
He really is getting
I'm seeing if I have another pencil.
You know,
Because I might not.
I just had like a kid with these telephones there where I like got a little scared.
I'm sorry.
All right, Carter. I don't have any other
No, I'm
pencils,
not gonna insult you.
She said
Besides
she
this
showed me
one.
yesterday where I, like,
but I need this to be returned
Oh, yeah,
because
that's fine.
to replace it nowadays is $300.
What?
They don't make them anymore.
There's a pencil here.
That is crazy.
It's got a plasmodium grip. You'll never be the same.
I'm gonna break it.
You better not. It's $300.
I'm not gonna break it.
All right, so
Do you feel the
I'm going to go back to my problem and figure out which of the x's should be 0.
Okay.
Here it says, while the spring is initially unstrained. So that must mean this is 0.
What?
Okay, so what do we know about amplitude and x? How are they related? We've got this lovely formula here for amplitude. How are amplitude and x related?
Amplitude is x, isn't it?
Well done, Nina. So now that you know this, you have all of this information.
Yeah.
And so you can put this into x in your long formula here.
Wait, what do we know is X?
Hey, amplitude. Amplitude is x.
Okay, but
But I'm also gonna go like really simple.
But what?
Max.
then we have two X's, don't we? In our total formula?
Because one of them is 0.
Because our answer for the initial would be square root of kxf squared divided by m. Wouldn't it?
See that again?
How do we define v? Don't we need v max?
We have it.
How? Go.
Our equation.
Yeah, but isn't that has an x in it? Doesn't that?
No.
What?
V max does not have x in it, dude. What are you talking
Where'd you? How do you find v max?
Oh, we don't know amplitude is what you're saying.
We don't know amplitude, that's true. Damn it. I wish this was easier. Ah, fuck. Edit.
So you did an x in there and it's
Okay, so I'm gonna put this here. All right, what is it we are looking for?
the initial squared.
We know that.
Yeah.
Do we?
Yeah,
Uh-huh.
we do. We're looking
Yeah.
for amplitude. So
Oh,
we're looking for x. Final.
x. Oh.
Because
oh.
x would give us amplitude. Right?
So wait, then we didn't need the. Did we not need the a equals v max?
Man, we need it.
Okay, I'm so confused.
All right, let me show you.
Okay, I can find x. Here, watch this. X is mv initial squared divided by
But,
k.
but we're not looking for x though. We're looking for k, aren't we? Isn't that the
We have
Yeah.
120.
Oh no, I'm sorry. Amplitude is what we're looking for.
Yeah.
Okay, my bad. Okay, so I'm just gonna simplify my formula here so I don't have all of this nonsense.
I got it.
Okay.
X equals square root of mv initial squared divided by k. Because the 1/2 cancel out. Then you just divide by k and then you square root the whole thing. So I guess a equals that.
Sir.
My brain is so like tired. I can't even think through these things.
I
I'm
don't
just
know
using
how
my
you're like alive.
I'm just using my notes. I'm not. This is me just regurgitating what I've already done. I mean, I'm not thinking about anything. Okay, so then A. Oh no! Why is it? Why do you do these things to me? Oh. I wouldn't have needed to have done that at all.
Yeah.
Awesome.
So you.
I wouldn't have needed to have used like VMAX and
Yeah.
wouldn't have needed that.
That's what I was saying.
Thank you, Carter. I'm sorry.
No, that's okay.
This literally is just me regurgitating the things. So then we have 8 meters per second squared divided by K is like 124.
Did you include the maths in
So then when I do this math, I get 0.0718. God bless you.
Thank
Meters.
you.
there? I got 0.072.
Yeah, same thing. Same thing. Okay, good. So I'm glad that we thought through this, and I'm sorry for leading you astray there. There was, but this, like, don't lose this in your notes or like wherever you wrote it.
All by the
What'd you get after that?
Where's the creative pen? Let's do this. Because this is an important thing to know.
Gotcha.
Even though we didn't actually end up needing it at all.
Ooh, stars.
It can do smiley faces too.
Oh, that's awesome.
And what is this? Oh, little daisies.
Aw.
And
So-
this is snowflakes.
Whoa.
What is the homework?
The homework is, good question, 27, 28, 29, and 38.
27, 28, 29.
On page 305.
Look at this, is ridiculous.
305.
I'm too lazy to change it, so we're gonna go with it. 305 to 306. Numbers 27, 28, 29, and 38. This is ridiculous.
It's so like fuzzy.
It looks weird on the screen. Oh, that was a half hour. We worked for quite some time today.
Alright,